Okay, so now we have Andrew and Victor working out problem number 44. Number 44 in particular deals with a circle graph. And circle graphs are important because you have to understand that the equivalent of a circle graph needs to, or not the equivalent, but the total for a circle graph is 1. Whether it's 100%, 1 whole, or if they give you decimals, everything needs to add up to 1. And you gotta keep that in mind because each piece will contribute to it adding up to 1. And like I said, and like I've told you guys in class, you know, especially when it has percentages, all the percentages put together need to add up to 100%. Sometimes the problem will ask you how much of it is not, or how much of it is. Either way, the not and the is both need to add up to 100%. And it's always important for you guys to understand that. So without further ado, Andrew and Victor.
The spinner below is divided into equal sections. Kyle will spin the spinner one time. What is the probability that Kyle lands on an even number or a number less than 7?
First, we will circle the numbers less than 7, which is 6, 2, 3, and 4. And then we will check mark the even numbers. And then the probability would be 7 out of 5.
Now, fixing this one, I want you guys to understand, okay, that in a graph like this, it's asking you for a combination of information. Whether it asks you for 2 sets of that particular data, and then combine them to contribute to the total probability. So, they're gonna try this one again.
I fixed it and it's 4/5.
So if you notice here, he automatically saw his mistake when he said 1, 2, 3, 4 out of the pieces contributes to the 5 whole. So it's the probability is 4 out of 5. Does that make sense? Now you can say that the probability is 4/5 of landing here. Obviously you're gonna have a big chance, right? The big chance equaling to almost the whole entire time. Every time you spin, you're gonna land on one of these. And you can turn this fraction into decimal, that decimal into percent. In this case, Andrew's gonna go ahead and turn it into a decimal and then to a percent, okay? And you can do that with any other probabilities. So first, the fraction to a decimal, and then you go from the decimal to a percent. So how much was it as a decimal?
And the decimal point, maybe.
Look,
No.
actually,
Yes, it's
5 goes into 4, and then work from there, okay? So if you notice here, his answer was 0.80. So after the 0.80, all he did was 1 swing, 2 swings, and ended up at 80%. And that's how you turn a decimal into a fraction. Now, one of the things that I've also explained, and everybody does this automatically, but I want you to, I want to re-emphasize the fact that, and the reason why you do two swings, like right here, is because you're multiplying by 10 every single time. So 0.8 times 10 is 8, right? And you multiply it times 10 one more time, and you end up with 80%. And you multiply it 10 times 10 because that equals to 100. Percent is dealt with 100. Okay, so anytime you talk about percent, you're dealing with something out of 100. And that's the little swings you do to the decimal. Again, that represents multiplying times 100. Again, if you go the other way, you're dividing by 100. So very important for you guys to understand. Everybody does it automatically, but and now instinctively, and it's very important for you to understand why you're doing it. Okay, so thank you guys.